Welcome to Lunchbox Sessions, bite-sized industrial training.
Hello, this is Carl from LunchboxSessions.com. This is part 3 in a series on hydraulic schematic reading. We examined the hydraulic power unit down at the bottom in our video, How to Read Hydraulic Power Unit Schematics, and we looked at a fair amount of the directional valves and pressure valves in the video, How to Read Valve Section Schematics. Well, this time around, let's start at the top and work our way back towards the middle. We're going to find out about some very interesting features that help protect cylinders that are lifting vertically a very heavy load. We're going to learn about velocity fuses and about shock valves. So let's zoom in and get started. When everything is running normally, there isn't a lot to say about the valves that you see mounted immediately below the cylinders. This pressure valve here, do you remember which one this is? It's a symbol for a standard relief valve. It's there as a shock relief valve just in case some type of extraordinary load from above was to shock against the line leaving the cylinders. At the bottom end, something was to shock against that and cause an excessive pressure spike. And that, of course, would only be the case if the cylinders were already raised above their resting point. But if we were to stop the cylinders, say, at this mid-stroke point, and some type of shock hit against the cylinder rods from the top, well, keep in mind that our directional valve down below, currently out of view, has a blocked port. And in fact, even before we get to that cylinder, we find out that this entire load is resting against a pilot-operated check valve just below the diamond-shaped flow rectifier. So at the moment when this shock might come along and hit against the cylinders from the top, there is no other relief valve available in the system other than this shock relief valve. So it's mounted right close to the cylinder to provide protection where that pressure spike, that shock, might occur. Well, let's just move over here to the right cylinder for a moment. Here's a form of shock against the vertical cylinder coming from above. We've just simulated a boxing glove that appears out of nowhere, and if you're watching that shock relief valve, you see that it opens up and relieves fluid through it back to tank on the vertical blue line. So that's the purpose of the shock relief. Moving back over to the left side, we could see that there is a pressure transmitter. That's a symbol for a sensor or a transducer that reports this pressure signal to a controller of some sort. We also see the symbol for a normally closed shutoff valve. When the triangles are darkened in, we know that that's meant to be kept in the closed position. Should something go very wrong with this hydraulic system, this valve could be opened and the cylinders could be gradually lowered down if there was some issue with not being able to operate the hydraulic system. So sort of an emergency release valve. Well, let's find out what else might go wrong. Have you seen this symbol before? This is a bit of an unusual one, the velocity fuse. But again, you'll really only see it in circumstances where gravity is posing a serious risk or some other type of hydraulic line burst might cause a serious emergency. So in this case, with these two cylinders lifting a very heavy boom, if the flexible hose, that's what's indicated by this semicircular hydraulic line symbol. That indicates there's a length of flexible hose. It doesn't indicate how long. You can't assume from it that it's a very short hose. And in fact, on this machine, it is a lengthy piece of hose. If that hose was to burst, what would happen? Well, potentially the boom and those two cylinders could come crashing down. Well, let's simulate that circumstance. Let's cause a burst line right here. Watch the vertical line, and let's see what happens with the velocity fuse. So we've caused a burst to occur, and as a result of the hose break that we've got there, The velocity fuse detects that the flow rate across it is so high, it happens so quick our cylinders don't even move noticeably, and right away the pressure differential on the two pilot lines, one to the left pilot head and the one to the right-hand pilot head, are so different from each other that the valve just snaps shut. And in fact, there is no way now of reopening this valve unless you come along from the bottom supply line with pressure once again. So I think that right there gives us a clue as to what we might need these shutoff valves for if a hose was to burst and we needed to make some repairs safely and restore this system back to normal operating state. We might first have to bleed down the cylinders if they were raised up, get them into a safe position, then perhaps do some hydraulic work safely once the load has been set down, not the least of which would be to replace the broken hose. That's all for this time. Thanks for watching.
We have hundreds of interactive resources like this live schematic, so you can try out your wild ideas without blowing anything up. Get started at lunchboxsessions.com.